Hi everyone, welcome to my YouTube channel Tech Data Engineer. So in this video we will see what is transformations, what is transformation architecture and all, okay? And what are the different algorithm which we are using in transformations, okay? So in our previous video we have seen that what is LLM, what are the applications of LLM and what are the algorithm which we are using in LLM, okay? So now we will see the transformations in this video. Okay. So what is transformation basically? So transformation is nothing but it is a deep learning architecture. Okay. So there are multiple architecture in the deep learning which we are using earlier like RNN, recurrent neural network and LSTM. But transformations later came into picture because there are lot many disadvantages earlier we found in case of RNN or LSTM. Because of that transformations comes into picture. Okay, so transformation is basically the foundations of LM like GPT, bot, llama, palm. So whatever the LLM we are seeing these days, so all are based on the transformation. So transformations have two mechanism. One is the encoder, one is the decoder mechanism. Okay, so whatever the LLM we have seen, either it is based on encoder or decoder. Okay, so we will see the architecture of transformations also, which we are showcasing here. I'll explain what is encoder and each and every step and decoder also. But first we'll see what is transformation. So it is a deep learning architecture. So that was introduced in year 2017 by Vaishnavi. Okay, in paper attention is all you need. Okay, so now, nowadays, so for now, we can understand that transformation is nothing, it is a deep learning architecture. Okay. So, what are the algorithm associated with transformation? What is the core heart of this transformations? We will see in the upcoming video. But for now, we can see what is transformations and what are the disadvantage earlier found with the algorithm. So why transformation comes into picture. Okay. So before transformations, model like RNN, recurrent neural network, and LSTM. So we are used for language, but they struggled with certain things like long sequences. So if we are giving the long sentence or paragraph as a prompting and all, so they are lagging in that case. They don't have the parallel processings. So whatever the sentence or prompt we are giving, they are using in sequential manner. They don't have parallel processing. Okay, they don't have the options to remember the long dependency. Okay, they don't have options. Okay, so that because of this all things, transformations comes into picture. So the transformer solve this problem using a mechanism called self attention. So this is the self attention is the core of this transformer. Okay, so now we will see what is key idea of transformer. Okay, so instead of so how transformer basically work. So instead of processing word one by one in order, like how RNN used to do. The transformations look at the entire sentence at once. Okay, so whenever we are giving the prompt, okay, like the cat sat on mat because it was tired. Okay, so when model see it, attention help it to understand. It refers to the cat, not the mat. So how we are giving the attention because it is reading all entire sentence at once. It is not reading line by line. Okay. So the key idea of transformer was self attention, attention score and attention mechanism, self attention mechanism. There are lot many other algorithm associated with that, but self attention is the core of this transformation. We need to understand that. Okay. So, so instead of processing word by word, which was earlier we are doing in case of RNN, so in case of transformer, we look the entire sentence at once, okay, and then figure it out. Which words are important, how much each words are related to each other, and based on their attention score, we are finding out the we are generating the next sentence or next word, we can say. Okay, so now if we are seeing the example, the cat sat on the mat because it was tired. So when the model see it, attention help to understand it refers to the cat, not the mat. Okay. So that way, self attention help to find out the attention score, and based on that, we are generating the next word. Okay. Now we will see the what is the transformation architecture. So transformation has two main parts. One is the encoder part, where bots we are using or whatever the translation LLM we are using, that all are based on the encoder. So encoder basically read the input, and what is the decoder generate the output. That whatever we are using in the case of GPT or any text generations. Okay, so DPT is based on the decoder technique, and bot is the based on encoder part. So now, so before going to this architecture, transformer architecture, we will understand first few things related to this one. Okay, so we have certain component inside the transformer. One is the input embedding. So what is input embedding? So we will not explain here in the details. So we have NLP video where we are explaining all these things related to what is tokenization, what is vector, what is embedding system and all. So we you can see there, but here we will explain just functional thing. So what is input embedding? So input embedding is words are converted into vectors. So vectors are nothing but it's like a number. Okay. So mathematical terms is easy to understand and relate. That's why algorithm converted into the mathematical term. Okay. So embedding is something like words are converted into vector. What is positional encoding? So sentence transformer do not process word in order. We add position informations. Suppose we have the cat sat or sat cat. So here the order matters. So that's why positional encoding is also important. Next is the self attention. So self attention is basically the heart of the transformations. Okay. So for each word, it calculates how much attentions to pay to other words. Okay. That is relations. You can consider alternate as a relations. So here attention score is basically the relation between each word. Okay. So for example, he want to bank to he went to the bank to deposit money. Okay. So attention focus on deposit and money, financial meaning, not the river. Okay. So bank is something related to deposit and money, not with the river. Okay. So that way we can understand based on this attention score, and which context it is giving self attention help in that case. Okay. Context awareness. What the next thing is, what is multi-head attention? So multi-head attention is something, it is same like attention, but instead of attention view, the model looks at relationship in multiple way. Okay. So self attention is the single way to look the perspective between each words, but multi-head attention, it will see the multiple way, you can say multiple way, multiple perspective between each word. Okay. So now the next thing is feed forward neural network. What is feed forward neural network? So after attention, information is passed through the regular dense layer of transformation. So we have seen the neural network like an architecture. There is a hidden layer, different layer. Layer is something like a different level of neurons, and that is getting passes through the different layers. Okay, that is we are using in the case of feed forward neural network here. What is residual connections or layer normalization? So that basically help to stabilize the training and prevent information loss. So if there is information loss or stabilizing the training things based on the different hidden layer, it will help in that case. Okay. So we understand these things are related to transformation architecture. Now we will understand the transformation in architecture. Okay. So in that case, there are two things. One is the encoder mechanism, one is the decoder mechanism. So encoder have input embedding, positional encoding, multi-head attention, encoder layer, multi-head attention again, then the masked multi-layered architecture. Okay, feed forward network, and then output probabilities. Here also, if you'll see output tokenism, multi-head attention, decoder mechanism, decoder layer, then multi-head attentions. So I'll explain each and everything step by steps. Okay. So first we will understand the encoder thing. Okay. So 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 here in case of input processing, words are turned into vector. that is called embedding. Okay. Then we have the positional encoding, add words in the order. Okay. So positional encoding, words add into order. Okay. Then we have the encoder layer. So each words look at all other words using multi-head attention. So in case of encoder layer, if you talk about this encoder layer, what we are using the multi-head attention. So what is multi-head attention? Each words look at all other words using multi-head attention techniques. Okay, and capturing meaning in each context. So it will handle all the context. Okay. Then we have the a small feed forward network refines it. Like encoder output is reached to present the whole word into whole input sentence. Okay. Okay. So this way we have the encoder output. We have the encoder output basically that a rich representation of the whole input sentence. Okay. Now, if you talk about the decoder techniques, so decoder predicts token one by one. Okay, so it has the masked attention, cross attention, feed forward network. So what is masked attention here? So attention is nothing but looks only at past word, not the future. That is called masked attention. What is crossed attention? So cross attention looks at encoder output, the input sentence. Okay, and what is feed forward networks? So that refine into help decoder to know both what is already generated and what the input means. Okay, so both way it will help. And then we have the final step. So final step is the decoder output goes through the softmax function. Okay. So decoder output is goes through the softmax layer, and pick the most likely next word. Okay. And the word is feedback into decoder, and that process repeat until the whole sentence is generated. Okay. So until and unless whole sentence is generated, this process repeated again and again. Okay. So that is the architecture of our transformations. Okay. So now understand with the simple example. Okay. So suppose I have a sentence called I love pizza. Okay. So how encoder works and how decoder works. So encoder meaning of each word in context. Okay. So how decoder works. So decoder step predict like a suppose so I wanted to change like I love pizza to different meaning like a French meaning. So how encoder will do? Encoder understand meaning of each word in context. So that is the encoder word done. How decoder will do? So decoder how it will do? Step one predicts the jammy. Step two predicts the la. Step three predicts the pizza. If we are transforming to French, then what we will do in sort. So in sort means encoder is helping here to understand the input. Okay, and what decoder is doing? Decoder is generating the output step by step using encoder help. So both the cases, so it is not only like encoder and decoder the separate layer here. Sometimes encoder help to understand the input and decoder help to generate the output. So both way they are correlating to each other. Okay, both way they are helping while training the data while generating the output in encoder and decoder mechanism. So that is the brief of transformation architecture. Okay. So now coming to the next part, why next part is like why transformations are powerful for LLM. Okay, why earlier there are different deep neural networks which are not powerful as LLM. Okay, so scalable. So scalable that can handle the very large data set and parameters. Okay, so in LLM we have the millions of billions of parameters. So scalable is the one of the things which makes the LLM more powerful. The next thing is the parallelism. So unlike RNN, they can process the entire sentence at once. We have the parallelism things. That is the faster training, long context. So in case of LLM can remember the dependency across long documents. Okay, so they have the long memory context. Okay, they flexible works not only with the text but also the vision, audio, multimodal task. Okay, so LLM can work with all these things. So because of this, all the feature LLM are more powerful than earlier. So in simplified flow, if you'll see first text generation like GPT So input prompt, what it will, we are giving the capitals of Francis. So what after that, what it will happen? It will do the embedding and positional encoding. Then self-attention mechanism comes to find the connections between capital and France. Then decoder predicts the next token as a Paris. So this way it will basically work. Then repeat until it complete the output. So this is a simple example which will tells how our basically LLM work. Okay. Now we will see what is the core algorithm inside transformation. So the main algorithm inside transformation is self-attention. So self-attention is nothing but it is the scaled dot product attention. So we have three things. Q, query, key is the key, V is the value. So how attention is calculated? So attention is calculated basically we are passing through a softmax functions, and that is the so that we will see mathematical term in the next video. For now we can understand this example, but we will see through the different example how we are calculating the attention mechanism for each words. Okay. So this gives the weighted sum of word relationship, meaning the model learns which word to focus for each word. So the mathematical behind our attention mechanism, this query, key and value. Okay, and we are doing the self attention by SQL dot product. Okay. So what are the other algorithm that is used in transformation apart from the self attention? So we have the multi-head attention that runs parallel, run multiple self-attention mechanism in parallel. So different view of relation that is called multi-head attention. We have the feed-forward neural network, which I have already seen that is the after attentions vector are passed through a standard deep learning neural network that is called FNN. Then we have the positional encoding between the two words. Okay, like since transformation do not process words in order, is an schedule or learned positional algorithm encodes word order. Okay, so this all mathematical things we will see in the different. Then we have the residual connection or layer normalizations. Okay, so this all are the things which we are helping in case of transformation. So for now we can understand that we have the self attention, multi attention, FFNN, feed forward, positional encoding, and these are the algorithm which we are using and helping to train the to understand to train the model. Okay, then we have the training algorithm. So during training, transformation uses next token predictions, casual language modeling using in GPT, masked language modeling used in Word, optimization. We have the SGD. We have the other optimization. We have the loss functions for cross entropy loss. Okay, so these are the things which we are using for training the data. Okay, so in short, if you'll see here, in short, main algorithm inside transformation is self attention, that is the skill dot product attention, and we apart from that we have the supporting algorithm like multi-head attention, feed forward network, and positional encoding and normalization. And we apart from that we have the training algorithm like gradient based optimization, ADAM for ADMW, or with cross entropy loss. So these are the things we will help to train our model, LLM model. Okay. Thank you. Thanks for watching.